Hello everyone, welcome back to my YouTube channel. I'm Sashank of CSCIA and here's my roll number. Thank you. So, hello everyone, welcome back to my YouTube channel. Now, let us discuss the overview of graphs and their applications. So, first of all, let us see what is a graph. If you're in a town, if you're in a city, there are different kinds of locations in a city. So, location A, location B, location C, location D. If you want to go from one location to other, you take a road. And from B to D, there is a road, B to C road, and A to A to C road, A to D road. Now, I will name these locations as vertices and these roads as edges. Now, congratulations, you have made a graph. This is nothing but a graph. A graph is a combination of edges and vertices. These vertices are connected by these edges. Our vertices can have any number of edges. Next, introduction of graphs. Graph is a mathematical representation consisting of vertices and edges. Graph can be used to model relationships and connections in various fields. Understanding graphs is essential for studying complex systems and data structures. Graph is a combination of nodes and edges. It is a mathematical way, and it is like the uh, the picture of a computer. The picture of a computer. We can understand that this is a graph, but how can a computer understand? Like we can understand that there are different kinds of roads between different kinds of locations. But how can a computer understand this kind of thing? A computer understands all these things using a graph. Now, what are the types of graphs? There are several types of graphs: undirected, weighted, unweighted. So, let us take an analogy of directed graphs. Let us explore the directed graphs first. In a city, there are different kind of there are locations A, B, C, but there is a single way path. You can only go in one direction. So from A to B, or B to C, or C to A. So there's specification of direction here. So this specification of direction makes this graph a directed one. So if you have direction in a graph, then it is a directed one. You can't go back from B to A. You can only go from A to B. This is a directed one. What are undirected graphs? So suppose A and B are friends. A is a friend of B and B is a friend of A. There's no direction here. Direction is not very much useful here. So this is an example of undirected graphs. If there is no direction, that is undirected. If there is some kind of arrows or directions in the graph, then it is a directed. So tree graphs, these are not required for us. We are not going to discuss them here. So like complicated versions of this. Now coming to the weighted graphs. These weighted graphs are like the cost. The cost of going from one location to other. Location A to B it takes 2 rupees. Location B to C it takes 3 rupees. So from C to A takes 5 rupees. So these are nothing but weights. So these weights are in weighted graphs. Weighted graph is a combination of edges plus vertices plus weights. These weights help in determining the efficient path. So these are very much helpful in graphs. Weights. Next, graph representations. There are two kinds of representations of graphs. One is the linked list, the adjacency matrix representation and the adjacency list representation. Now let us understand what is a matrix representation. So there is a graph here. So here there is an edge between B and A. So there is an edge between B and A. So between B and A you have an edge here, and there is an edge between D and B. So D and B you have an edge here. So D and A, you have an edge. So from D to C, you have an edge. D to E, you have an edge. All these edges are represented using ones, and without, if there is no edge between two nodes or vertices, it is represented by 0. So this is an adjacency matrix representation of a graph. Coming to the adjacency list representation of a graph, here there is an array, and for each indices in array, there is a linked list, and array starts from 0, right? So 0 is represented to A, B, C, D, and E, and so on. Now for A, there's linked list which says how many of these points in the graph are connected to A. So from the graph here, A is connected to B, D, F, and G. So these are in the form of linked list, and this linked list is stored in the first index of array. Similarly, every linked list is stored with that particular vertices. So this is a representation of adjacency list representation of a graph. So traversal methods of graph. We have two different kinds of traversals, the BFS traversal and DFS traversal. In breadth first search traversal, we just go from root node, this is the root node, the top node, to 1 to 2 and 2 to 3, 3 to 4, 4 to 5, 5 to 6. This is a horizontal way of representing the graph. This is used to find the most fastest and the fastest route in a graph. Next, coming to the coming to DFS, the depth first search. Here, by the name itself indicates that we are going deep into the graph and searching it from the root. We go from 0 to 3 directly, 3 to 1, 1 to 4, and 1 to 0, 0 to 2, 2 to 5, 5 to 2, 2 to 6, 6 to 0. So this is a depth first search of the graph. Now, what is the use of depth first search? It is used to find the solutions to puzzles, the maze problems. Like if it encounters some kind of edge in a maze, it just backtracks. Backtracking is essentially in DFS. Goes to 3, it backtracks to 1, it goes to 4 again, backtracks to 0. So this is nothing but the DFS search. Next, applications in computer science. Graphs are extensively used in computer science for network design and optimizations. They play a vital role in database indexing and searching algorithms. So we use graphs in searching algorithms, social networking, and recommendation systems heavily rely on graph structures to analyze relationships. So something like if there's a website link and there's a website, there's some kind of edge connecting between them. This is nothing but a graph representation. The web graph. Applications in biology. Biology, graphs can model relationships among species or genetic interactions. Like there is an ancestor, and from this ancestor, there are different kinds of ancestor A, B, C, and D species came, and from B, three different species originated. This is the representation in biology. This is the genetic representation, the genes. This is a form of graph. This is tree graph. So next, they are used in bioinformatics for analyzing protein-protein interaction networks, and they are used in understanding the spread of disease through population networks. So, person A, let us, in a person A, he had a disease called COVID. He is affected by COVID. So, before knowing that he is affected by COVID, he has interactions between three persons, B, C, and D. So, all these three persons will have COVID now. So, COVID is a communicable disease. All these three persons have. These three persons interacted again to three persons. So, did you see here? This interaction is a edge here, and the person is a node or vertex. So, this forms a graph. This is used in finding like how much far the disease has been spread from a person. So in these kinds of things, graphs are useful. Next, applications in transportation. So how are graphs used in transportation? We all have come across Google Maps. We just use it in our daily lives. these Google Maps, how it works. If you want to find a shortest distance between A and B, if there are three routes, it always finds the efficient route for us. How does it do it? It just uses different kinds of algorithms of graphs to find the efficient route between A and B. So Google Maps uses graphs to find the efficient route between A and B and displays the route to us. So like to go from store 1 to 3, there are three ways. You can go to store 5, 2, and 3 this way, or go 2, 1, 3. The most efficient way is to go from short 1, short 3. So this is a more efficient way. If we don't know that there's a way to go from short 1 to the directly, we just go through the long ways, which is some kind of time waste for us. So these kind of things, graphs are very much useful in transportation. It reduces the time between the supplies. They are helping optimizing routes and minimizing travel time in logistics. Traffic flow analysis and urban planning utilize graph efficient city designs. Even designing a city uses graphs to connect between different kinds of locations. Applications in social networks. So here, let's name this person as Jack, and this is Rose. This is Steve. So Jack and Steve are friends on Instagram. So this is an Instagram. Instagram. Please don't mind about my handwriting. Just try to understand the concept here. So Jack is a friend of Steve is a friend of Jack, and Rose is a friend of Steve. So Rose is a mutual friend of Steve. Rose is a mutual friend of Jack here. So Instagram recommends Rose to Jack. So this is a practical application of how is it recommending Rose to Jack? Because there is a edge between Steve and Jack and Rose. So what Instagram algorithm thinks is like there is some kind of connection between Rose and Jack. There may be some kind of connection. So it just recommend Rose to Jack. So Jack, what he does, he just follows Rose. Because he knows her. So in this way, graphs are used in social networks. Social networks. They help researchers understand influence, communication, and information flow. Like if a person knows if a person is some kind of rebel here, and how many interactions he's doing with other parties around his hometown or around his bunker or something. This kind of things graphs, graphs help us to understand. And in Eurovision Games of 2018, different countries vote for different countries. So to understand how many countries a country have voted, the graph representation is very much useful here. Then emerging trends in policy. The rise of big data graph databases are becoming increasingly popular. The application of machine learning techniques to graph data is growing field of research. Graph neural networks represent a new frontier in deep learning enhancing data representations. So in databases, this is the example of a graph usage in database. In databases, graphs are very much widely used nowadays. It helps in fast retrieval of data from a database. So if you want to take some specific kind of data from a database, the different kinds of graph algorithms are very much useful in finding the data and retrieving it very fast. Retrieving it as fast as possible. So this is the practical use of graphs in databases. Conclusion and final for future perspectives. Graphs are versatile tools applicable in various domains, from computer science to biology. Continued research and development in graph theory will lead to new applications in engineering. Understanding graphs will remain crucial as data complexity and interconnectivity increases. And to conclude, graph theory is more just a kind of mathematical concept. It's a lens through which we can understand the complexities of our interconnected world. So if there is a connection between two things, graphs comes into play, and it plays a very vital role here. As data grows in volume and complexity, graph theory will remain essential, driving new insights in science, technology, and beyond. Continued research will likely uncover even more applications, making graphs one of the most versatile tools we have for tracking modern data challenges. The final thought, so these are the references I have used, and final thought is a mastering graphs allow us to navigate and make sense of the web of connections that define so many aspects of life and technology today. So I'll just post this PPT in the description so that we can just go through it and understand the concepts very clearly. If you have any kind of questions, please comment them down in the comment box. Please subscribe to my channel, like, share, subscribe, and don't forget to hit that bell icon just beside the subscribe button so that you won't miss our latest videos. This is my first video, guys. I think you understand the basics of graphs. If you have any kind of doubts related to graphs or any kind of concepts, please comment down in the comment box. I'll try to make a video on that. That you can understand them very easily. So please like, share, and subscribe, guys. Thank you. Bye bye. And living with a smiley face. Always smile. Bye, guys.